But think about CH3, CH2 is 29, right? So, but CH3 is 15, CH2 is 14. When you do mass spectra, of course, you should be very familiar with these small units and its mass, so you do not need a calculator. So, but if that's 29, that's not very unique. So all L can have that 29. Do not need to mention it, right? And 29 unique is because it's aldehyde. Aldehyde is COH, so 12 plus 16 plus 1, so that's 29. Since that 29 is strong, since you have carbonyl functionality that can stabilize that cation, so that will be strong. So you will see that strong signal, then you say, okay, this is very strong one. You probably have aldehyde functionality. So for 30, what's 30? We just talked about it. Yeah, so when you see a 30, you are very happy. Okay, I know this is a parameter. So that's a very easy thing. You hope to see it. So, yeah, and like 91, remember 91? Yeah, I just from yesterday to today, I do not know how many times I have mentioned that 29. So if you have exam, you hope you can see a 91 so that your question become much easier. So 105 is related to 91. So okay, so this kind of peak you want to remember. So and another thing you want to also mention many times, you want to watch on the even number fragment. So if your molecular is even number. Of course, if your molecular is an odd number, then you want to watch out the odd number map. Since it also needs two bond break to produce odd number. So for fragment, do not forget the nitrogen rule. Okay. For most of the fragment will be odd number nitrogen, then the fragment will be even number mass. Okay. So from there, you propose some piece of structure, then you put them together. You will get a number of possibilities. Then from each possibility, then you use your fragmentation knowledge to see which one fits the best, then you may get a conclusion. Sometimes you may not get a final calculation. You say, okay, this molecule probably for your knowledge it should fit to the spectrum. Then you have to check the library to compare the reference spectrum to do the final decision. So this table shows you some small mass, small piece corresponding to the structure fragment. So you want to go through this table to familiar yourself with these small groups. So then every time you see this group, you know you have this part of structure. So now let's have some real questions. So for this one. So this is a very small molecule, right? So you see what's the molecular arm, although it's elaborate, but why this is the molecular arm. So of course the spectrum you measured will not tell you it's a molecular arm. So you first need to say, okay, since this is the highest mass over Z, so that you're looking for a molecular arm, you're always looking for the highest mass over Z. And if you see this difference, so 84 to 69, the difference is 15. So 15 is a massive group. So that's very reasonable, right? So most time you see the molecular arm, you want to see the neutral loose. The loose, if within a reasonable range, generally that's the molecular arm. So all the number of electrons that thing is more like theoretical, more complex. Generally, we do not use that to do the analysis. Since that when you need to first figure out the molecular formula, then when you know the molecular formula, molecular is not a question. So, but that's a way to additionally check the conform, right? So for this one, and also the good thing is spectrum is so clean. So you do not have any questions, and also the molecular ion is pretty strong. This molecular ion just that low, and you still have many noise there. Then you will be hesitant to tell, but then from the beginning you know. And you see that I have a number of one thing you see is 56. Is that normal? So since your molecular is even number, when you break one bond, so even number splitting in half generally get an odd number, odd, right? So you have even indicate you have two bond equilibrium. So that must have some special functionality, like mostly you have a double bond, or you have a ring, you have to break two bond to form this even number, right? So now let's start. So 84, if you see this isotope, n plus 1. So here is small. Visually may not be tell exactly how many, but you can use a rule to measure. So if you rule measure this one, say this is 10 centimeter, and you measure this one is like 1 centimeter, then it's 10%, so you probably have 9 carbon. So, but here, if I do not measure, I cannot get a number. But if you measure, you probably can get this. Because the mass is there, then probably 5, 6 carbon, I think. But you measure, you can probably have 6 carbon. So, or 5 carbon, or 7 carbon. So, that's it. So, without measurement, then you can do the rule of 13 to try to get the formula. Then we can, first hypothesis is just the carbon and hydrogen. And we have not seen any specific signal for heteroatoms, right? So like you do not have the specific hydrogen. You do not see like dehydrated with hydroxyl group. You do not see the carboxyl group. You're not sure if you have a carbon there. So, but mostly looks like more oxygen. So, you rule 13 and 84 divided by 13 will be what number? Somebody do a calculation? Rule of 13, 84 divided by 13 is 6 plus 6, right? So then you can write the formula, carbon 6, proton 6 plus 6, 12. So you write the formula, there also now looks like, I do not know which set it is. Just never see this. We just have a normal PPT. It automatic caption. I do not know. Do you guys know just normal PPT presentation? You can turn on the caption.
You
should
be
able to.
Yeah.
I never do that. So that you see, and when you have a formula, you can calculate this double bond equivalent. So you can do a calculation, you know you have one double bond. So one saturation may not be carbon-carbon double bond, it could be carbon-oxygen double bond, right? So either way. So then that explains this even number of fragmentations. Since you have one double bond, you can do that McLaughlin rearrangement, right? So now you see the formula is so simple. Then you can write, this is a hexene, right? 6 carbon, you have 1 double bond. So then you can write hexene. Then the question comes to what is a double bond, right? And also this hexene doesn't have branch. So you can have branch in many isomers of branch in different places, right? So then you can write some hexanes. So you can still write more. So I just write, you can, like, this is just if you have linear, you have double bond 1, 2, 3, the position. And you can put a branch, you put the double bond on branch. Of course, you can also put the double bond here, the branch does not have double bond. And you can move the double bond to here. So that's for, if the double bond on branch, there's only 2 choices, right? So then you can have a double bond here, then you have the branch here, this is no double bond, you have the double bond here, or double bond here, they're all possible, right? So you write all these things, then you go detail to see if that fits to that representation. So since you have this McLaughlin rearrangement, so then that way need you have a gamma carbon have a proton, right? Forming the 6-member ring and the proton transform, right? So that tells you the double bond at least have 1, 2, 3. At least you have this proton, then you can form the 6-member ring to transfer that proton to have a stronger McLaughlin resonance. So for that reason, the double bond, if you put the double bond here or here, then put the double bond here, then the McLaughlin will not happen. So basically, you rule out this structure. Like here, this one, you do not have the gamma carbon proton, so you rule out this one. This one looks like still work. This work, right? So that's the thing, you rule out something. And the stronger 41, so you have a very strong 41. So strong 41, that indicates you prefer this structure. Since you have a branch here, so you break from branch, that's a perfect 41. And because you have the bond stabilized, so that 41 is strong. So for this reason, although I did not write all the structure, for this reason, I prefer just this one. That's structure. So this is a really hard to figure out the structure. So it's just the one proton mass spectrum. You determine the structure without any other information. So basically, when you propose a structure, you do it again to fragmentation. And also, as we said, you immediately have few of them fits to this one, then you see which one is the best. Like the 41 here, of course, the 41 you break from here also can be 41. But that 41 probably do not see this strong. So this branch that's preferred fragmentation, right? So that's the first one, structure. Any question? No question? No question, next one you do it. Okay, this one.
Okay.
Can we make it bigger?
Oh, there's a 91, there's a
Dramatic ring.
Not sure.
Oh, yay!
There's a 91, so there's an aromatic ring.
Yeah. At least from this class you remember 91. So C91 immediately you can write a structure, right? So 91 is ring and So the branch could be longer branch, but you cleavage from here, you still have chopping. Or you have benzene ring, you have other substitutions that you get from other places, then chopping. So this 91, so you already, so the molecular mass is 136. You already know 91, so most majority you already got it. Okay. Yeah, so you start from a base peak and a very characteristic peak, then working on the molecular.
Seems to be
So now you want to working with the molecular arm.
is this one?
So for this one, it's so strong, so that's not a question. That must be the molecular arm. Of course, you want to. What's it? Could be 17. You do not have too many choice. 17.
17 can be an
What can make 17?
OH.
Yeah. OH, right?
Yes.
So, yeah, and another possibility for 17.
NH3.
Yeah, NH3. So there's only two possibilities. No way to others can make 17. So, and you can now you can think it's NH or OH, NH3 or OH. Anybody can tell me what's your choice? Since this difference is 17, so the 17 should be an hydroxy or an amine group, NH3. So if it's NH3, what will happen? Yeah, you have nitrogen apply nitrogen group. So this is a molecular mass is even. So if it's NH3, you have to have another nitrogen to make it even. So you already have 91. You only have those small things. You can think if you put 2 NH, what will be? So then that way you can rule out NH3. And also NH3, you have to have this double bond. It's like elimination reaction. Since for NH, the functional group you have an NH. So if you want to remove NH3, you have to have an elimination reaction to cleavage two bonds. So when we're talking about amine, we says that for amine that elimination reaction is not very common. So but this become a very strong peak. So that's not we do not have 100% solution. If that happen to be the structure when you do a elimination reaction forming a conjugated system very stable, it could be. Okay. But most of the scenario will not. So this does not look like it's very strong. So not feasible, we say not so common. Not so common, so most time you do not see some. Occasionally you see a weak one, right? So this seeing strong, so we have hydroxy. So basically you want to have a hydroxy here. Adding to some place. This one.
Yes.
So here you may have a side chain, you may not have a side chain. For this part, you may have a substitution in place. Okay. So, and if you continue, so from here to here, what's the number?
That's 130.
45.
Minus 45.
So 136 to 91.
45. 45.
A little bit.
45.
The 5 is correct. Okay, 45. So it looks like everyone need to go back to elementary school. so you have to be like after more practice, you will be very sensitive with these maths. 35 almost nothing except the poly. Okay, so all other carbon proton cannot if you see 35, you have to expect that you have chlorine. So, yeah, so that's the way when you do run calculation, you should have a feeling that. I say 35, then there's only thing chlorine. So then you want to see that n plus 2 that strong one, right? So 45. And or if you see the difference between here,
It's 28. 28?
419,
28?
So 28 most commonly corresponding to what fragment? So
CO. CO.
yeah, CO or carbonyl or CH2, CH2, right? So that's one. So if you combine CO and OH, what's that functionality?
Alcohol?
CH, CO,
Yeah.
so you have CO and OH. What's carboxylic?
Alcohol.
So that's 45. So
It's an alcohol.
well, from here to here is 45. You already have the carboxylic acid. You connected. You got it. Already since 91, 45.
They don't have
36.
These
Right?
are not. These are not.
So basically, you got a structure. Of course, the question is the substitution is OMP, you do not know. Right? So for that information, probably you have to check the library what's a small differences between OMP. And so this fragmentation fits very well. Of course, you can,
The position.
for this time we did not talk about the isotope. So but you can see you do not have the N plus 2. So you already rule out of all this heteroatomy. So you do not see something also helpful for the identification. Okay. So for this one, if you like do not use any knowledge to figure out formula, you say, okay, I just start from that. We use rule of 13 to try to figure out the molecular formula. So if you do a calculation, you get this one. So you say, okay, you have three double equivalent. Okay. So, but when you see first thing here, you know you have oxygen. So then you say, okay, I replace 16, I use that 136 minus 16, that's 120. So 120, you do this calculation again. So you get another formula. Then see what's HDL, then see the end fragment to get more information. So from there, step by step, you figure out the molecular formula. Of course, when you experience, you see this one as fascinating. I think you already get a big chunk. So that's yeah. So. Yeah, so then every time when you propose structure, you always use this knowledge to figure out all these major signals. Of course, this small one, that's the benzene fragmentation, then that's not so important, so generally you do not need that. And many times, not every of these fragmentation is so easy to explain. Because after small fragmentation and mechanism can be very complex as well. And so that
It doesn't make sense to say.
you may ignore it. But some the weak signal do provide the important information for the structure. So depends. So okay, then this one looks like pretty good. Okay, this one.
Amine?
So what's certain?
Choro structure.
Namai.
Yeah, yeah, so looks like you can graduate now. So everybody immediately see that 30 unusual is an even number, small one. That's very unusual. Most time you cannot see it. You see it, you're happy. Easy question come. So 30, so that's, you know this is a primary end. And primary, and here, also, do not forget molecule R. So that's any, that's 73 indicate just one nitrogen, right? So that's these two combined tells you clearly your M is correct, your one nitrogen is correct, they verify each other, right? Then what do you look for? So now you still need a molecular formula. So yeah, so you can use the rule of 3, but you can remove the M since you already know you have an M, and it's not covered. So you can subtract it at 14, then you do a calculation to see what you get. So then you can get a formula, right? So and 30 to here, 30 to 73, what's the difference? Yeah, 43. So now you graduate from elementary school. So 43 is very common, right? Remember what's 43?
Isopropyl.
Yeah, propyl. So it's just 3 carbon chain. So then the 30 is the CH2. Then you have a propyl. So only question is if you have a, this one could be like a branch here. Only one possibility. You do not have any isomer, right? So then how do you differentiate this molecule and this molecule? What do you expect from the aspect?
That is 15.
So either it's a linear one, if you have a branch, have a isopropyl.
You can see pick 29.
20.
We had isopropyl. You see a peak at 43, very strong, because it's a secondary carbocation.
Yeah, so since if you have a branch, you broke from branch, so this secondary carbocation is strong, so you expect 43 have a reasonable intensity, right? So did you see 41, 42, 43, 40? So you did not see very good abundance of 43. So you can rule out this one.
Yes.
So it's probably,
Linear.
this one is probably pretty sure. It's
So it's
not have like say, OMP, you do not know.
Yeah,
I'm pretty sure just this 1, 2, 3, 4. This one. Okay, you guys can complete it early today. You did pretty well, so.
Kuna piki kwake ya kwanza ya 29.
Should I go check the sheets?
No, well, I think maybe let's just, I have a few and we completed the lecture. So we have a long tea break and lunchtime. So for this one, what we get? So
So this picture is 16.
chlorine. So hiyo ndogo.
What is this book of flexibility?
Is that a 96 or a 98?
98.
But it's true.
Is it a block 13? So
98.
8,
Answer kwa
13.
nani?
Sawa. Hiyo ni block 13. Kwanza na block 13. 88 divided by 13. 98 divided by 13. Hii 7.
7, 7, 7.
So n is 7. R
10, 7, R 6.
7. 7. So ni C 7. H 14. 7 plus 7. Yeah.
It can be.
Can it can.
Yes,
But
it can be this.
So probably we can complete the division. So actually, if we have
use 25.
That is unique.
so if we can.
That's even
Somebody.
Sijaandika hapa. I think so.
Yeah, let's see if we have time.
91 really.
91 hakuna kabisa. Hakuna hata signal kabisa.
So hatuna hiyo ring.
Hatuna ringa. Kutaka chukua kwa kazi zetu. Tuko na 35. Tuko na 35. Tofauti after 63.
63.
Yes, tuko na 35 kwa ringa. Tofauti after 63. So kwa 63 tunaona
63.
unaelewa?
Itakuwa ni
63 divided by times 4 times
4.
52. Then
So C4.
C4. Then 11. 11 plus 4, 15. For example. Sini 11 zimebakia. Ires
Yeah, plus 4. Hoja tuone if we have 4 cup.
Hebu 63 minus 27 ni ngapi?
So after we go for tea, it's not the plan. You can't go before lunch. So lunch, we can make lunch right after tea.
36. Kuna shida hapo. Ati kuna nini? Kuna mlima. But angalau tumejaribu kuna kulori.
12
Yes.
minutes, something like that, that'd be good.
Supposed to be Macau. How
So
can
they
I
would
get
get to
50?
around here, so.
As it makes sense.
Does it make sense?
Video.
Yeah.
So to introduce
think
Chiromo.
This year we can do. But I think that's true.
Plus?
The first cohort did that, and they liked it.
Mwisho hakuna ring.
And that was the only one that got to the
Na benzine peke yake benzine.
Benzin bila si romantic. Si benzin tu by the si romantic. Una saturation. Tunasema by the way. Inaweza kuwa kicyclopentane,
Wacha tuende tunywe chai.
63 kuna mali nime sijaiwahi. Tuende kwenye chai la kitaka. Lakini chlorine tumedecide iko. Sio
The inverse segment does 20, that's, you said it's possible 27, right? Yeah. So then that'll be the H. The 63 minus the 40 gives you 28. But if H was that, if you use H, then it's 27.
No, I mean, I asked, they said they're gonna try, because I'd rather not. Just
So is it I think it's either 28 or 20.
Like less
So I can either way it.
aldehyde ni ngapi? Aldehyde tumesema ni strong one na favorite.
Yeah.
Well, even the security gate.
But you know, they're trying to do
Past that, and go under the bridge.
Panga umepanga kamonsi na
Panga tu.
umepanga kamonsi na
Yeah. Oh, that's all. So we should be taking tea in 5 minutes.
Tuweke maji chlorine itakuwa.
then chlorine labda iko hapa sana. Unaona kama ni system ni 1 2 3 4
12 times 4 12 times 4 12 times 4
12 times 4
ama
Do you pack up your room?
kuna kitu hatujawahi kitu niko karibu.
And I'm still trying to work out situation. They're trying to figure out if it's better to leave from the pharmacy or from the hotel.
Basi hapo kuna H moja basi imereplace na kitu. There's a possibility. There's a possibility kwa kuna another function ina replace with somewhere. Alafu make chlorine.
ndio imake it kweli. Yeah, I get it.
So hebu tuwe moja alafu tufanye hivi 48
Yeah.
1 2 3 4 5 6
8 plus 48 56.
56.
Then what can we put here? You have a point, man.
Tunajaribu. 7 ni noma. 7 ni seven na kwa nini?
You already getting something. You say 35, that's the most important body structure. Find the most difficult part and cannot figure out.
Hiyo tunaisha.
6, 7, 8, 9. Itakuwa 9 plus 6.
But you see this different. Not a big thing. What's that?
Kwa sababu inamaanisha what it means. There's a very likely that I say hydrogen more than hydrogen several more than one.
Moja tuangalie hiyo
Relationship.
Gano.
Why you have a very strong
Yeah, but then
so what's
65 kuna kitu alisema za mwisho mwisho. Hiyo 65